Hello, my name is Gonzalo, and today I'm going to be teaching you about types of triangles. Let's go.
Alright, so let's get started. So let's start with the basics, the real basics. So what is a triangle? A triangle is basically any polygon that has three sides. So for example, this is a triangle, this is also a triangle, and this is also a triangle. So these three are triangles. But what we're going to cover today is how we classify these triangles. And there are two different ways to classify these triangles. One is through its angles and through its sides. Through its angles, there are right, obtuse, and acute triangles. Based on their sides, there are equilateral, isosceles, and Escalene triangles. So let me write that over here. Right, obtuse, and acute. And based on the sides, there are equilaterals, isosceles, and Escalene. So let's start with the ones that are classified by angles. Alright, if you want to group triangles using their angles, there are three main types: right, obtuse, and acute. A right triangle are triangles with one angle that is 90 degrees. The other two in a right triangle add up to 90 degrees. If you add this angle over here to this angle over here, you'll get 90 degrees. And usually the way we depict right angles on triangles is by drawing a square. This always indicates 90 degrees. So for a right triangle, we need at least one angle that is equal to 90 degrees, which is portrayed with a square. And then there are obtuse triangles. These are triangles with one angle that is more than 90 degrees. So this is one obtuse triangle, and it looks this way. So a nice way to identify this is by comparing a right triangle with an obtuse triangle. You can clearly see that, like, if this triangle were a right triangle, then it would be like this, and you see that it goes past that line, meaning that the angle is greater than 90 degrees. So this is right here is an obtuse triangle. So the only requirement for any triangle to be an obtuse triangle is for it to have one angle greater than 90 degrees. And then our last type of triangle is this one. It's called the acute triangle. So in here, in an acute triangle, all of the angles are going to be less than 90 degrees, meaning that if we were to draw a right triangle line, this is what I'm going to call it, it's always going to be less than that. So in here it would be like this, which is pretty confusing. So it never goes past the right triangle line. So this basically means that all angles, it's really important that you identify this as all angles are less than 90 degrees. Alright, so if you're trying to group triangles using the length of their sides instead, there are three main types: equilateral, isosceles, and Escalene. Equilateral triangles are triangles that have sides of equal length. Because of this, all of the angles in equilateral triangles are 60 degrees. So since all of the sides here are of the same length, we portray them like this. We put a line through it. This means that this and this and this are all equal in length. So if this were to be 1, the other side would be 1, and therefore the other one would be 1 as well. And in here, since all of the angles add up to 180, 180 divided by 3 is 60 degrees, all of the angles of one equilateral triangle would be 60 degrees, 60 degrees, 60 degrees. So the two main important things to remember is that all side lengths and angles are equal. And therefore, all angles are equal to 60 degrees. So let's move on to isosceles triangles. Isosceles triangles are triangles with two sides of equal length and two angles of equal length. So in here, these two are equals. And just like here, we're going to portray them with a line. So these two sides are equal. Therefore, these angles are going to be equal as well. So if this was 1, this would be 1. If this was 2, this would be 2. This would be 2 as well. And if this was 30, this other angle would be 30 as well. So a thing to remember here would be that two side lengths and their corresponding angles are equal. Right, and let's go to our third type of triangle. These are Escalene triangles. These are triangles that have both no equal sides and no equal angles, meaning that this angle over here is different than this angle over here and this angle over here. Usually to portray this, we draw angles with different semicircles. And yeah, so this indicates that all of these are different. So to indicate that these are different, that the side lengths are different, we'll do one line over here, two lines over here, and three lines over here. So in here, you can also, so for the isosceles triangle, you can also portray it this way. This indicates that this is different to these two. So a thing to remember is that there's no equal side length or angles. So in here, we see some real life uses of triangles. So here we see three different examples. One's a pyramid, the other one's a pizza, a slice, and the other one's a pine tree. So what do all of these have in common? They all are resembled after an isosceles triangle, which, if you remember, is a triangle that has two sides. So these are some forms of isosceles triangles you can find in real life. On the other hand, in construction, for example, in bridges, this little bridge over here, so cars would pass through here. Let's say it's a really nice car. Couple right triangles give great support, and also are really efficient. So there are just right triangles coupled. You have probably seen this on bridges. Usually metal structures are follow this pattern. And yeah, all of these are right triangles. You can probably go outside and you'll find many different triangles that you just learned about today. I hope this helps, and thank you for watching.